Relative velocity in a plane. In this video, we are going to discuss about the second type of relative velocity in a plane, that is object in medium motion. Let us consider an example to understand what is object in medium motion. For example, if you are trying to cross a pond with a boat, then since the pond has steady waters, you can directly cross in a straight line. But if you are trying to cross a river that is flowing, so the water has some speed, in that case, when you try to travel in a straight line, you end up going in a slanted direction. How do you apply the formulas? Consider an object in a medium. The arrow here suggests the direction of the medium. If the object moves along the medium, then the resultant velocity will be velocity of object plus velocity of medium. So the resultant velocity of the object with respect to the earth or the stationary frame of reference will be the sum of velocity of object and velocity of medium. Now the same concept is applied in one-dimensional motion. What if the object tries to move at an angle with the medium? In that case, to apply the vectors, first we draw velocity of object along the direction of the object, then join along with velocity of medium along the direction of medium. Hence, by the triangular law of vector addition, we have the resultant vector along the given direction. Now, if the angle between the initial direction and final direction is theta, then velocity of the resultant will be equals to velocity of object into cos theta in this case. Based on the given situations, these directions, the value of theta, the resultant values will keep on changing. Let us have a look at this example to understand relative velocity for object in medium. The engine of boat drives it across the river that is 1800 meter wide. The velocity of boat relating to water is 4 meter per second directed perpendicular to the current. Given velocity of water with respect to shore is 2 meter per second. Find the velocity of boat with respect to the shore and how long does it take for the boat to cross the river. Now, as you read the question, try to imagine the given situation. So, first we have a river that is 1800 meter wide. Then the boat is traveling at 4 meter per second. So, let us call it as velocity of boat with respect to water, because that is mentioned in the question itself and it is perpendicular. So, velocity of water, that is 2 meter per second, that is denoted by velocity of water with respect to shore. Now, this is the situation. Hence, the resultant will be along this vector. Let us call it as velocity of boat with respect to shore. It subtends an angle theta with the velocity of water. So, what we are supposed to find? We have to find the velocity of boat with respect to shore, that is we have to find VBS, and the time taken by the boat to cross the river. We have the distance, so if we find the speed, we can find the time. Let us find the resultant velocity first. Velocity of boat with respect to water is 4 meter per second. Velocity of water with respect to shore is 2 meter per second. Since this is a right angle triangle, we can directly find VBS, that will be square root of velocity of water shore square plus velocity of boat water square. Substituting the values and simplifying, we get the answer as nearly 4.5 meter per second. So, the boat will travel at a resultant velocity of 4.5 meter per second. Now tan theta, in this case over here tan theta will be equals to what? Opposite upon adjacent. So that will be nothing but BW upon VWS. That will be equals to 4 by 2, that is equals to 2 of course. Hence theta will be equals to tan inverse 2. If you use the logbooks, you can find the answer as 63 degrees. We need to find the value of theta because we have to find the resultant velocity. So to define velocity, we have the magnitude as well as direction. So here the value of theta 63 degree will give us the direction of the resultant velocity. For the second question, how long does it take for the boat to cross the river? For that we change the arrangement of the figure in such a way that we have width of the river over here, resultant vector over here, the angle inclination with velocity of water shore and velocity of boat water as it was previously. Now time is distance upon velocity. In this case time will be width upon velocity along the width of the river. So that will be resultant velocity into sin theta. Now from the figure it is evident that resultant velocity into sin theta is nothing but velocity of boat with respect to water. So that will be 1800 upon velocity of boat with respect to water. Substituting the values and simplifying, we get the answer as 450 seconds. The next thing for you to do is practice as many questions as you can. Pick up different reference books from different publications and try to solve questions based on relative velocity in a plane. You can also do parallel practice for independent motion and motion in a medium. So you can erase even the slightest margin of error. Also, like the video, leave some comments and share the video with your friends and subscribe to the channel if you haven't already.